Hello, this is a demonstration of the Reagent system, which enables you to interact by voice with ordinary web pages that contain no special instrumentation. As part of this demonstration, we'll be building an ontology using terms and information found on web pages. In cases where Reagent is unable to relate your terminology to terms found on the page, it provides simple mechanisms by which you can teach it your domain vocabulary. To start with, let's open a web page containing a table that includes information about the Premier League teams for the 2018 season. Watson, open the table for the 2018 Premier League. We see here that we've opened a page from the Sky Sports website, a third-party sports organization, and it contains information about the 2018 Premier League. After opening the page, the Reagent system injects a transparent layer on top of it, which detects salient content and associated hidden metadata, attaches listeners for user interactions with that content, and then allowing us to query for and manipulate the content on the page. For example, we can mouse over this row here and ask the following query. Watson, who is this team?
The team is Tottenham Hotspur.
And the system is able to answer our query, combining our gesture on this row with this column header to give us our final answer of Tottenham Hotspur. However, we see outside of this column, the table uses abbreviations and symbols to represent the rest of the columns. Some of the columns, such as this one here, has hidden metadata that helps to tell both users and Reagent what this column stands for, in this case, position. However, Sky Sports does not provide this information for all columns. An example of this is this column here, which stands for draws, but is labeled with just a D. And Sky Sports does not provide any further information, which prevents Reagent from automatically detecting and determining what this column stands for. As such, we cannot issue a query such as this one. Watson, how many draws does this team have?
I'm sorry, I cannot find a column for draws. Please identify a column for it.
As we can see, the system was unable to answer the query and asks us to help fill in this gap in its knowledge. To see the system's full understanding of this table, as well as get us along on our task of building our ontology, we're going to add this table into our ontology as a team entity, which will show up in the bottom right here. Before we do that, however, we're going to use Reagent to get rid of this last column, as it contains information that is not necessary for our ontology. And so one of the features Reagent gives us, as I mentioned, was the ability to manipulate tables. In this case, we're going to delete this column. And we can do it by mousing over the column and issuing the following query. Watson, delete this column.
Column deleted.
And we see the column has now been deleted and is no longer on the page at all. And now, to add this table using this column as the entity name, we can issue the following query. Watson, add this table as an entity using this column. Watson, add this table as an entity using this column.
Added table as entity team.
And we see here now in the bottom right, we've got a new entity on ontology, team, and that several of the attributes for the entity are not filled in, such as that D, as we mentioned earlier. Now, to help Reagent better understand the content on this page, we can mouse over each column and identify it, such as this. Watson, identify this column as draws.
Updated column is draws.
And we see now the ontology no longer has a D, it has draws instead. And given this, we can now ask this Reagent system a question about draws, similar to the one we asked earlier. Watson, how many draws does this team have?
The draws is 7.
And we see here the system is now able to accurately answer our query with 7, which is correct. Going beyond just simple querying of a single column, however, we can query information over combinations of columns. For example, if we mouse over this column here, which stands for goals that the team has scored, we can ask it to tell us how many goals they've scored per game. Watson, what is the value of this column per games played?
Value of F per played is 1.76.
And we see that because we have not identified this column yet, it uses the abbreviation, and it gives us that sum, or the goals for the team, this column here, divided by this column here. Additionally, we can access information across down the entire column. So for example, if we mouse over this draws column again, we can ask the question, Watson, what is the average of this column?
The average of draws is 5.8.
And so we could also ask it for max, min, and other type of questions, if we so wanted. And finally, continuing with the theme of manipulating the content on the page, like we delete a column, we can also reorganize the table to show a column we more care about. For example, this table right now is sorted by this column, but we might want to sort it by number of wins overall through the season. To do that, we're going to mouse over this column here and issue the following query. Watson, sort the table by this column descending.
Table sorted by wins descending.
And we see now Tottenham is now above Chelsea as they have 2 more wins. Bournemouth is above Newcastle United, and there's a few more examples as we scroll through the table. And we could sort it by any of the columns that we have identified thus far. And so, we could issue more of these types of queries, identify more columns, but for the sake of time, we're going to move on to the next new page that contains the roster for a team and players for the team. And so we're going to just look at this team, Manchester United. Watson, open the roster for this team. For the purposes of this demo, we have hard-coded the link between each team and their on the previous page and the relevant page on ESPN. And that's just for the purpose of this demo. In a real environment, we may go through Google or something otherwise to get to this page. And similar to the Sky Sports page, we are now on ESPN, again, a third-party organization that we are not affiliated with, and we can, look at these tables. We can see that unlike Sky Sports, they provide all of their columns with metadata so that we can immediately start querying information off the page. So we can mouse over this row here and ask the query, Watson, how many appearances are there?
Appearances is 25.
And the system is able to answer our query, similar in fashion to dealing with the team entity type queries. And now, to continue on with our task of building an ontology, we're going to add these tables as a player entity. And we're going to issue a very similar query like the one we did before with team. Watson, add this table as entity player.
Added table as entity player.
And we see here we've got now a new entity player, and that all of the attributes are already filled in automatically. We don't have to identify any columns for the system. And so now we could, issue very similar queries as we did with team, averages of columns, resort the tables, etc. More interestingly, however, is that we can provide a relationship between these two entities and then start asking queries that stretch across the two pages. So let's add our part of relationship between team and player. Watson, add a part of relationship between entity team and player.
Added relationship.
And we see here we now have our entity where players are part of a team. And now we can ask a query that starts on this page and gets information from the other open page. Watson, how many wins does the team of this player have?
The team has 19 wins.
And so the way this works is that the reagent picks up that this h1 tag as a header attribute to identify the content on the page, determines that this section here, Manchester United, is connected to the previous page, or the content on the previous page, where if we look at it, we've got Manchester United. And therefore, the players on this page are most likely on the team that is in this header, and then we've connected to this row here. And we see the system had answered 19, and that is correct. And so we could ask increasingly complex cross-table questions, build up data sets with this sort of information, etc. Hopefully this has proved an interesting demonstration of the reagent system. Thank you.